All right. This is, let's see, what's today's date? It's the 26th of May, 2014. And I believe that makes this SolderSmoke 161. And we have with us a special guest this week, Pete Juliano, N6QW, also known as W6JFR. That's the way I always think of Pete, because that's the byline that he used on all those articles. He's been a ham radio operator for more than 55 years. And has operated from some really interesting places, including Midway Island. His articles have appeared in QRP Quarterly and Sprat. He's got a really interesting range of activities in ham radio that I think make him a really excellent guest for SolderSmoke. He's interested in everything from boat anchors to microcontrollers. And in many cases, he takes boat anchors and microcontrollers and blends them together. We'll talk about that in a minute. He did so many amazing projects. One of them, the most amazing and inspirational for me, was his rebuild of the Heathkit HW101, a rig that's near and dear to my heart, in which he replaced that dial with some glowing numerals. And I thought that was very cool. As a matter of fact, I've recently been sort of motivated to go in there and try to do that kind of rebuild on the HW101 itself. He combines old tech and new tech, Arduinos, SI570s, even a device, Pete, that I really liked it when you wrote this series of articles on the 40673 dual gate MOSFET. I mean, there's an oldie but a goodie. I mean, Doug DeMoore built and designed so many rigs using the 40673. I think it's fantastic. Pete's built the Paraset, one of the tube type Parasets. He's got an amazing YouTube collection. One of his projects was called the KWM4, which was sort of a solid-state version of the KWM2 or something like that. Was that right, Pete?
Yes, that's correct. Yeah.
All right. Then we have one other thing I'd like to point out that as I looked at the picture of his ham shack as a kid, and I knew so many things resonated. Our backgrounds, I think, are very similar. He had a DX100 there on the table. I had a DX100. And up on the wall above the DX100 was a certificate from the Rag Chewers Club, the RCC. We were both members, in good standing of the Rag Chewers Club. One other thing I'd like to finally mention, because this is something that is also kind of in common. A lot of ham radio people will have this characteristic. It's not widely known, but Pete plays a mean guitar, a Feder Strat. And so that's something he has in common with many radio amateurs, including our friend out there in India, Farhan. So, Pete, welcome, and it's a great pleasure to have you here on SolderSmoke this week.
Thank you very much, Bill. I'm glad to be here with you and share a little bit of information from my experience with regard to ham radio activities, specifically building. That's what's so great about our hobby, Bill, is that a lot of people just like to operate, and some people like to build, and some people like to build and operate. And so I'm in the category I like to build and get them on the air, get them working, and then find the next new project.
Yeah, and that Rag Chewers Club certificate and the DX100 that you had there on the bench as a kid, Pete, it really got me thinking about something that I saw in a paper that you really wrote, and that's kind of the rag chew orientation of your operations and how, really, I mean, as much as we love CW, as much as we all cut our teeth on CW, really, when you start to talk about rag chewing, I guess the most efficient way to do it is with phone. And I myself, over the years, have sort of made a transition from CW to phone. And looking at your articles and looking at your projects, I get the sense that you've made kind of a similar transition. Can you tell us a little bit about that?
Yeah, yes, and I guess, we're always sort of in a hurry, and with the CW, you got to think a little bit harder about uttering words and how you phrase things, and you want to make sure as you're sending CW, it doesn't end up being a sloppy mess. Whereas on phone, you can break and have input and comments back and forth. It makes it just a little more efficient. So I think that's what sort of caught my ear. The other thing too is that worldwide, at least it seems to me that QRP activities on sideband are really kind of fascinating, in terms of having relatively low power and be able to work those DX stations. So that was another aspect of it as well, is to be able, just as we're communicating here, not by CW but by voice, that's what caused my transition to focus on sideband versus CW.
Yeah, I went through the same thing. Also, I just find that it's I don't know, it's I think it's a much more technically kind of interesting thing to do. You know, it's great to send your message across the world, but there's something kind of almost I don't know, there's something very specially kind of intriguing about sending your voice across the world, and I think that's one of the reasons why when Fessenden fired up there on Christmas Eve, everybody was so amazed because now the human voice was coming out of those boxes. So I guess we're part of that transition. Pete, when I looked at, and the other thing I would mention about, voice versus CW, we have to face it that a lot of the new radio amateurs who are coming into the hobby
Right.
do not have roots in CW, and that's fine. I mean, I really have no objection to that. Technology moves on, and I mean, I think it's not really a good idea for us to say that home brewing is for CW and QRP is for CW, because of course it's not, and we could do great things with phone, with sideband phone, and I think that's our topic today. I think that's what we're going to talk about: home brewing for sideband, and I think you're the guy really to talk to, because you've had so many great successful projects, and I mean your YouTube, you've got such an amazing YouTube channel. You could be kept busy for days or weeks there. We're looking at all kinds of great projects. But so I noticed in your paper you talked about some key ingredients for success in sideband homebrewing. So I think the first one was a library.
Yes, absolutely, Bill. And that's the thing is, first off, the internet is so amazing with just a wealth of knowledge. And I found that, I'd say, oh, I'll go back to the internet. And then after a while, you forget where it was located and what have you. So I said, okay, let's do this by a process. And the process was to set up a series of files on my computer so that I could have a repository of information, things like data sheets about transistors, pinouts. I've smoked quite a few transistors because I said, oh yeah, that's a standard, and it wasn't. So having a good library and having an organized library is very, very critical. And you can store projects, other kind of technical documents, pinout information, spec sheets, and what have you at your fingertips in an organizing fashion. So if you want to build something, you can quickly go to that library and find the information that you need. So we've got the computers, the hard drives are very large nowadays, so why not have it at your fingertips? And I think that's really important.
I think so too. I mean, if you look, I've got behind me there, you can see the bookshelves, and it really does sort of, you really need a library. A lot of times you'll see on QRPL and other places people saying, well, what book should I get? And it's the problem is the answer is, well, all of them, because
yeah, right.
what I find is that different authors have different ways of presenting a particular technical topic, and when you're trying to understand something, sometimes you'll look at the book and you could read it, that particular book, 100 times, and it's just not going to click for you. Whereas if you go to the next book, the next author, he might have a way of presenting it that suddenly makes that technical mystery no longer mysterious. I remember as a kid, I really had only the ARRL handbook, which is, don't get me wrong, it's a great book. But on many of the topics that I was trying to understand, for some reason, the people who wrote that portion of the handbook weren't really speaking to me. Whereas if I moved to a different book, it would really, really click almost instantly. And as a kid, I didn't realize that. So I had to move beyond the one book model to the many book model that you see back there.
You're right, and I wanted to interject. I guess one of the authors that I thought was really terrific about that was Doug DeMont. He would take a project and he would explain it to you in a way that said, "Oh yeah, I understand that." Whereas you get a very technical paper, and you say, "Well, what's that mean?" And you just didn't have the tribal knowledge. And I think that's where Doug really shined. Is he realized who his audience was. People may be starting out for the first time, or this was their first project, or maybe this was a new area for them that they just didn't have that tribal knowledge as such to make it a successful project. And Bill had a real knack for that. I think that's important. I think you made a really key point there is you got to find somebody that talks your language.
Yeah, and you know, and have a large collection of resources to go
Right.
to. And I agree. Sometimes the technical stuff, because they're most often engineers, and in their mind they're writing for other engineers, so they make
Right.
a lot of assumptions, and a lot of these assumptions will not necessarily be valid if the audience is in fact amateurs who might not have all the technical background and might not speak the same jargon. The other thing you mentioned, of course, and this is really important, is to have an arsenal of test gear and tools. And I see you've got some pretty impressive machinery behind you there, Pete. So maybe tell us a little bit about that, but also tell us about what your general thoughts on test gear and tools.
Right. Well, right over my shoulder is a manual mill, a 3-axis mill, which is kind of really helpful to build different pieces of hardware. And what you can't see sitting to the left of the screen here is a 3-axis CNC mill. And I was sharing with Bill a little earlier that only cost me $250,000 for that mill. And what that was involved with is sending my son to engineering school. My youngest son is a mechanical engineer. So in repayment, he designed and built the CNC mill for me and taught me how to use it. So that's kind of the world's most expensive CNC mill. But really, if you have access to something like that, or even the manual mill, you can do a lot more than just it's, to me, I find it's a lot easier to construct things with versus just direct Manhattan style, is to use the nylon square method. You can cut those on the CNC, but really go back to the basic hardware. And I wanted to share with you that because I have published some articles, I receive inquiries via email, and someone will say, well, gee, I built this thing and it doesn't work. And I'll say, well, are you able to test it? And they have no test equipment. And so there's some basic pieces of test equipment which could be really helpful in the shack, and it doesn't cost an arm and a leg. One of those, as an example, is a little RF probe. Build yourself a little diode RF probe so you can put it on a DVM to test for the presence of RF. Another is a single transistor test oscillator, which is very useful, like a signal tracer. I mean, these are basic pieces of equipment. Of course, it would be nice to have an oscilloscope, because sometimes you have to troubleshoot things and you have to go through parts of the circuit. And if you have no pattern on the scope, there's something wrong with that particular circuit. But getting down to things like an ammeter. Many times you want to measure current going in, or static current. So something like a 0 to 1 ammeter, and you can find those relatively DC ammeter, relatively inexpensive in various catalogs. And that's a real helpful piece of equipment. A DVM and test oscillator, and a general coverage receiver is a good piece of test equipment if you've got one of those. So you need to not start with your hands tied behind you. If you're going to do this, you need to make an investment in some of the basic test equipment. And beyond that, of course, it's all a matter of resources, how much you want to spend.
Yeah, but I think you're right. I mean, you don't have to spend a lot, but you really do have to be able to do these basic tests. Certainly a DVM, a digital voltmeter, a digital multimeter, something
Right.
that you could pick down up at the local Radio Shack store for not too much money at all. In terms of the oscilloscopes, I've struggled with scopes, and I've had all kinds of different scopes. Right now, if somebody was to come to me and say that they were getting started in homebrewing and what should they do, I would recommend one of these new digital oscilloscopes. I picked up one from Rico for, I think, about $300 or $400, and I have it. You can see it right back there. You can see it. It's a small box. It's got a very low footprint on the bench. They work. It's amazing. They really do great things, and they have other pieces of test gear built right in. For example, there's a frequency counter inside that scope that is really fantastic. So when we get into our discussion of some of the sideband gear that we've been working on, these capabilities become very important, and they do prevent you from just sort of scratching your head and looking at this mass of electronics and saying, "Oh my gosh, it's not working. What do I do?" I mean, we've all been there. I've been there and done that. But it's a lot more fun when you have some tools in your arsenal.
If I could interrupt,
Go ahead.
interrupt you here, Bill. It's funny you should say that, because just about a month ago, I took delivery of a Handtech 200 megahertz digital storage oscilloscope, and it's a 2-channel job, and I paid $450 for it. And you're right, it's got a built-in counter in it. And just recently, I had to set a BFO crystal on the right frequency, and I just looked at the output and just tweaked it until I got the frequency, the exact frequency on the oscilloscope face, and I'm there. I'm done.
This
and
thing,
I'm saying, wow.
no, it's amazing. This thing will do the math for you, too. It's got all kinds of math functions in there. So if you want the output in RMS, it'll give you the output in the RMS. If you want to do some power calculations right off the bat, it'll do the calculations for you. And I know there's a lot of capabilities in there that I haven't even really begun to take advantage of. But I think that's a fantastic way to go. But you need a lot of other little things, too, and things that you mentioned, such as a simple crystal oscillator. The general coverage receiver is very important, too, because sometimes people will come to me and say, well, the thing is not working. And I'll say, well, is the oscillator oscillating? They'll say, well, I don't know. How could I tell? Well, if you have a general coverage receiver and you know that the oscillator is supposed to be cooking along at 5 megahertz, just put the radio next to it, tune to 5 megahertz, and see if you hear something. I mean, but it's funny. Like you say, this is in the area of tribal knowledge. We all kind of know this because we've been doing this since we were kids. But if you haven't been doing it, how do you know? It would never occur to you to do that, you know. Before we get started talking about filters and sideband, I think we should spend a few more minutes kind of on a philosophical approach. And when I was looking through some of your papers, Pete, I was really struck by how you emphasize the importance of looking at a project in stages and constructing it in building blocks. I remember as a kid, I would get a schematic. I would see a schematic. I wouldn't really even understand what it was. I wouldn't even understand the different stages. I would just start building it. And at the end, I would have this big mass of electronics in front of me that wouldn't work. But I would have no idea why it didn't work because I had not taken a stage-by-stage building blocks approach. Maybe you could tell us a few things about that.
Sure, absolutely. And this is not something original with me. It's just something that Heathkit pioneered and a lot of others did. And that's to first I'd start with your block diagram, what you're going to build, and to break up the blocks in logical pieces. And when I actually start building, and I have a block diagram that I think is going to be satisfactory at work to satisfy the requirements that I've established, and I start at the back end. For instance, I'll start with the audio amplifier stage, and I'll get that working. So then I know that that's working, and it meets all the requirements that I've set forth. And then the next stage I'll look at is, say, the product detector and the carrier oscillator. So once I've got that working, I plug that into the audio amplifier, and with my little test oscillator that I just talked about a few minutes ago, I'll bring that close to the product detector, and if I detect it, I know the product detector, the carrier oscillator, and the audio amplifier is working, and work my way through it. And as a matter of fact, that same test oscillator, once you hook up a filter, you can go to the mixer stage and inject the signal in there, and you'll have all those stages. And as you point out, if you built a very complex project, you have all these wires. And as a matter of fact, I shared with you a photograph of a project I built that was on a breadboard that was over 2 foot by 2 foot. I love it. So if you had all that, you'd say, where do I start? Where's the problem? You would have no way of knowing.
Yeah. And, you know, I had that. I mean, and I'm going to reach over here just to show you guys. This is my, I'm not knocking things over, but this is the Hearing Aid 5 receiver. And it's a simple direct conversion receiver. But when I built it as a kid, I didn't really look at it in terms of blocks. I got the whole thing done, but the oscillator wasn't going. And it took me 38 years to realize that it was the oscillator. If I had looked at it as a stage-by-stage project, I would have realized that I had most of the thing going, and I just needed to kind of poke and tweak at the oscillator to get it to percolate. So I think that's a real good example. You also talk about use. Go ahead. You had something else to say.
Yeah. Well, I was going to say that once I have a block that works real well, yeah. I'll say, well, you know, I know its performance. I know how to build it. I know how it should work. there's no reason why you can't reuse those blocks over and over again. So many of the projects I work on has a standard audio amplifier stage that I know works, and I know what its performance is, and I know how to fix it, and I have some real unique ways of testing audio amplifier stages. I take my finger and put it on the input. If I get a hum, I know it works. So, I mean, no rocket science test equipment here, but I know the performance. I know what works. And so, you know, some have said, well, gee, you're not going to try anything new. Well, I may try something new, but at least for this project, I want something that works reliably, and I know what works reliably because I've built it before, and I know what its performance is, and I know if there is a problem, where to look in that particular block.
Yeah, and in terms of blocks, another thing that I do, in addition to knowing that it works well, sometimes I'll choose a circuit or a block just because I really understand it. There might be a better circuit out there that performs better or people like, but if I don't really understand that thing, I'd rather not use it. I'd rather go with one that I've kind of come to understand. A good example for me is, again, it's the mixer, the balanced modulator, or the product detector. It's the standard 2 diodes with a tri-filler toroid. Doug Dumore used them in many of his rigs. And I went through, a while back, the process of really understanding how each one of those components contributed to the balanced modulation or the product detection. So I'll stick with that. And I'm with you on that. If you've got one that you're comfortable with, you know what the inputs and the outputs have to be, you know that it works, it takes a lot of the uncertainty out of it. So, and I think Doug was a real champion of this. Remember, he wrote one of these articles about these mini components that he built. They were about Lego sized. And one would be an audio amplifier, one would be an RF amplifier, one would be a mixer. He put a whole series of rigs together with that.
Absolutely. By the way, I have 2 standards for balanced modulator product detector. Either one of these packaged units, like the SBL1 or TUF1 or ADL1, or I use 4 diodes instead of 2.
Yeah.
The 4 diode ring, and that works perfect. You're absolutely right. You know what the performance is, and say, why not? This will work.
Yeah, that's excellent. Yeah. Now, there's a phrase that you used, and it's related to this, and it's important, and I hope you'd explain this to the audience. Noodling. What's noodling all about, Pete?
Well, that's my terminology for doing a lot of thinking. And before I heat up the iron, I want to think about all the aspects of a project. And I want to think about what it is I want to do. As a matter of fact, in some of the articles I've written, I'll start out with a requirements list. I'll say, what do I want this to do? What do I want this circuit to have? Like, for instance, is it going to have an automatic gain control circuit in it? Is it going to have an automatic level control circuit in it? Is it going to have an RF amplifier stage in it? So I sort of want to really think all these things through, and I want to think about signal levels. I want to think about frequency scheme. I want to think about, is it a single conversion or dual conversion? And we can talk a little bit more about that as we further along here. So I spend a lot of time thinking before I turn on this soldering iron. I mean, so many times, I know in the past when I first started, first thing I did is heat up the soldering iron, start tacking components together, and then I'd have this big mess. And I'd say, boy, you should have thought about that before. As a matter of fact, I used the example noodling. Had I done a little more noodling when I built that tri-band transceiver that ended up on a board that was 2 foot by 2 foot, I didn't think real well about how this thing was going to be packaged in the end. You know, I had all this wonderful circuit that worked, but it's so big you needed a football field just to box it up.
Yeah, but I think you're talking about 2 different kind of related problems. I'm really with you on the think first, solder later right. model. I think that's something that we should all embrace. Now, I've talked about this a few times with the podcast. It's a variation of the design build sequence, and I myself have been guilty of getting that reversed. Build, and then later on thinking about the design. You end up wasting a lot of time. It creates a lot of frustration, and so I'm really with you. Think first, design,
Absolutely.
And then build, and spend a lot of time with that notebook, the pencil and paper, just sitting there drawing things out, and we'll bring a new phrase into the homebrewers lexicon. We'll give it to you, Pete. It's noodling.
Noodling, yes.
You've
noodling.
got that one. Trademark. Pete Juliano.
Well, even speaking to that end, Bill, when I worked on the KWM4, I spent a lot of time thinking about DFMA, designed for manufacturing and assembly, going back to my working life. And so many times people will build stuff that if you need to make an adjustment or make a change, you have to disassemble the whole radio just to do that. Yeah. And so when I do things today, I always think about how can I get access to the boards, how can I make changes, how can I make adjustments. And so I try to package things and give a lot of thought about where should things go in the box, in the final box, and what circuits may require future attention. And so those need to be predominant, so from an access standpoint. So again, this is the noodling part, thinking about, afterwards, how do I tweak this? How do I adjust it? So I think that's time well spent.
Yeah, and that's something I've come to realize more and more, that you really have to start out thinking about space and packaging before you start the project. And I've got a number of rigs around here that I just was so concentrating on the circuitry that the packaging became an afterthought. And it is important to think about how big this thing is going to be at the end, and how you're going to, what kind of box it's going to be in, all that kind of stuff. And it is better to think about it in the beginning. But you know what? I really admired that 2 foot by 2 foot breadboard that you used, the Heathkit HW101, because one of the mistakes that I've made over the years is I've always seemed to underestimate how much space I'm going to need for a rig. I start out with this PC board, and I start out thinking, wow, I'm never going to fill this thing up. I'm going to have all kinds of extra copper. And in the end, I'm trying to squeeze stuff up onto the walls of the box. I'm driving myself crazy because I don't have enough room. So I've come to kind of err on the side of caution. For example, these Videx rigs that I built recently, I thought that the boards were almost ridiculously large. They were like the size of a printer paper, about 8 by 11. And I thought, I will never fill that thing up. And sure enough, at the end, I'm using every available square millimeter. And so I like that 2 by 2 plywood HW101. Literally a breadboard if the kitchen was really big.
Yeah, absolutely.
Yeah, you also commented on that breadboard that you made a lot of contacts with it in that kind of breadboard mode. I love those kind of contacts. Sometimes I'm reluctant to take the thing and put it in the box because it's so much fun to have all the electronics there and exposed. So I'm really I'm with you, and I'm glad you told us about noodling and standard box. All right, maybe now, Pete, we could talk a little bit about the real subject for today's show, which is home brewing for sideband. Frank Harris has a great book called From Crystal Sets to Sideband. It's available free on the internet. It's a wonderful book, and he has his chapter on sideband is called, I think it's the Nobel Prize for Home Brewing, because he describes all the other projects you can get into, and then he presents kind of the difficulty of home brewing a sideband transceiver, which for many people I think is seen as a very, very difficult kind of endeavor or project, something that you should take on only after some kind of intermediate range or basic or intermediate range projects. Maybe you could tell us a little bit about you think about that. How difficult is it to build a sideband rig?
Well, I think, and I thought a little bit about this, Bill, because I've been at this a long time, and I've built a lot of sideband rigs over a 50-year period. And in the beginning, it was a lot more difficult than it is today. Of course, early on, they were all vacuum tubes, so you had all these tubes and heaters, and a lot of space, a lot of real estate. You had lots of opportunity for interaction, unwanted interactions. How you laid things out got to be really important. But the technology today has moved things right along, so that it's today I consider it far easier. One of the problems before was you typically had to purchase a package filter, and that was a very expensive item. Today, with the advent of availability of computer crystals costing 35, 40 cents a piece, you buy 10 crystals and you get 2 filters, so it's something that makes it much easier today because of the availability of components, the availability of a lot more information. I mean, the internet has been so dramatic in terms of sharing information and experiences. That just didn't exist before. Someone get 1 or 2 books and they'd be off running trying to build something. So today, I really see it as a much easier task. And I think from a cost standpoint, you can really build a kind of a bare bones single sideband transceiver around $50.
Yeah.
And matter of fact, I think you mentioned to me that in India, they can build the BEDX they can buy the parts for what, $5?
Yeah, I think it comes out to the rupee equivalent of $5. And
So-
but you're right. I mean, the thing about it is the crystal filter. I have sitting next to me right here, I have the Hallicrafters HT37, and it's a phasing rig.
Right.
And as you know, I mean, the reason it's a phasing rig, the reason they put all that additional circuitry in there was to avoid the cost of a crystal filter, because that was considered, that would make it even more expensive. It was quite expensive at the time. That would make it even more. But like you say now, and this is something I think that a lot of guys who haven't been in home brewing for a while don't realize, is that this computer revolution that we've been living through has had some enormous benefits for us. And one of it is this kind of ocean of crystals that are out there in all different frequencies. And like you say, you just buy a whole bag of them, and then it stocks the junk pile. And the other thing about the crystal filter revolution that I think has been going on that's great is that you really get to tailor that rig, because the bandwidth and shape of that filter really determines, to a large extent, the quality and character of the rig that you're working on. For example, in the 2 rigs that I have here, I have the BitX 17 and then I have my BitX 2040. And I checked the bandwidth last week. On the BitX 17, it's kind of narrow. It's just a little over 2 kcs. On the BitX 2040, it's much wider. It's a little over 3 kcs. And you know which one I like better? I like the wide one.
Yeah, right.
It sounds great. It doesn't sound pinched. I mean, the other one sounds fine. But I listen to the other one and I find myself sitting back thinking, gosh, that thing sounds great. Now, but the thing is, I have the opportunity now. I could go back into the BitX 17 and very easily widen it. You could have it your way. And it's really a fantastic time to be doing this stuff.
Absolutely, and that's a key point. Is all you need is a bunch of capacitors, and that changes the filter bandwidth. So pretty easy to do, relatively easy to do. Just if you know what you're doing, you can tailor that and tweak it. And that's another point. There's free software available that'll let you design a crystal filter using the same frequency rather than in the half lattice type. The older style, they staggered the frequencies of the crystals. Now with a ladder type filter, they're all the same crystal, so it makes it a lot easier. And it's just a matter of getting ones that are relatively close in frequency, like 50 to 100 hertz, and you can have a pretty good filter. As a matter of fact, I built a 6-pole filter that I think is superb. And you'd have to pay hundreds of dollars to get something commercially for that, and $10. There you go.
It's amazing, and I thank Farhan in Hyderabad for encouraging me to kind of get more involved in the characterization of the crystals and the design in the filter, because I had been doing it kind of just hit and miss, and I would get a project, I wouldn't really take the time to determine the characteristics of the particular crystals that I had in hand. But once you do that, and it's not that difficult, once you have that information, then you can plug that information into the software that you mentioned, and then it gives you really, really accurate information on how the shape and bandwidth of that filter, of the resulting filter, will be. And I recently described on the blog my experience in taking a look at what the predictions were, and then taking a look at the actual results in my rig, and there was an amazing coincidence. They were right there. So this is very, very powerful technology that's available to us for free. It's all free.
Yeah.
And I just think it's fantastic. Pete, maybe say a few words about the selection of the IF. This may be a little bit kind of the advanced course for this first program, but maybe just share with us some thoughts on how important it is for you to select the frequency of your crystal filter properly.
This is where noodling time comes in, Bill, where you spend a lot of time thinking about this. And if you look at commercial crystal filters, typically you'll see the ones in the range from about 3 megahertz to about 12 megahertz. And I think about the great gear, all 9 megahertz. The Helicrafters, the SR150, and that was 1.6 megahertz. Heath kits were 3.395. Galaxies were 5 megahertz. The Swans were 5 megahertz. So there's a very good reason for this, and part of that has to do with tolerances and getting crystals, because they usually rate crystals in parts per million, and so you think every time you go up a megahertz, that's a million parts. So typically commercial crystal filters and the homebrew filters are in the range 3 to 12 megahertz, and that's pretty much a standard. But one of the things you have to think about is unwanted mixing products. As an example, if you built a 9 megahertz crystal filter, or you used a commercial one, there's commercial filters available, and you'd say, gee, I'd like to put this rig on 17 meters, 18 megahertz. Well, if you used a single conversion where you're using just the IF with a local oscillator, that means the local oscillator's got to be on 9 megahertz. So you got a 9 megahertz filter, 9 megahertz local oscillator to get you at 18, and pretty soon you got all kinds of problems. And matter of fact, as you're going through the amplification stages, you're probably amplifying the local oscillator, which is slightly different. So now you've got 2 signals on one band, and you got unwanted mixing products. So sometimes you have to give a real concern to what that frequency is and what are the mixing products coming out of your local oscillator. For instance, if you used a 4 megahertz IF and you were going to put something on 20 meters, so you'd say, okay, 4 megahertz, I need a 10 megahertz LO. So the sum of those two is 14 megahertz. The subtractive is 6 megahertz. So you got to make sure that 6 megahertz signal, the subtractive part of it, is adequately taken care of in the filtering, bandpass filtering, low-pass filtering. So that choice of IF just can't be random. You need to think about the bands of operation. You need to think about your local oscillator frequencies, and you need to think about mixing products such as the second harmonic of this mixing with the first harmonic of that. So this is where noodling comes in. That's why when I built some 17-meter radios, I used a 4.9152 megahertz crystals because they were readily available, very inexpensive, and I found that if I mixed that with a 23 megahertz local oscillator, that the subtractive mix of that puts you right in the middle of the 17-meter band. So you need to sit down with some pencil and paper. And matter of fact, I think Collins Radio had a nomograph at one time that lets you look at mixing products, the second and third harmonics, and I think that's available for download on the internet. So you can see where you're selecting the IF and what's going to happen. Now, just recently I built a transceiver, a 2-bander, on 40 and 20 meters, and I've got a 9 megahertz filter in there, and that works out fine. But I would never put that radio on 17 meters because of the 9 megahertz IF. I mean, that was a conscious decision of mine.
Yeah, and in terms of noodling in this area, one thing that I've done that I think is useful is I just fire up an ordinary spreadsheet, and I'll plug in one column the kind of what the possible VFO or local oscillator frequencies are, and then I'll look out and I'll do times 2, times 3, times 4, and take a look at what the harmonics are, and I'll take a look and see how they're fitting in and how they might affect the bandpass, and then I'll start using that actually to start thinking about mixing products to avoid the kind of problems that you've mentioned. You talked about your 17-meter rig, and I thought it was really interesting, Pete, that you came up with an IF at 4.9152. When I built my 17-meter rig, I was really close. I was at 5 megahertz. And I'll tell you the reason. The reason I went with 5 megahertz is because I happened to have 23.1 megahertz crystals in another rig. Dale Parfit, W4OP.
Oh, yeah.
Yeah, years ago, built a Doug DeMoor bare bones super hat. He built it with the IF that was a bit different. He chose 5 megahertz. And then later on, he got tired of it. He sold it on eBay. I bought it. I didn't even really know Dale. Dale didn't know me. And years later, I started tinkering with it. And I started asking questions. And then later, we realized that I was working on Dale's rig that he had built years earlier. But anyway, when I built the BidX, I said, all right, I already have these 23 megahertz crystals. I want to go with a VXO. That's really good because they're so high, you could shift them quite a bit. And I said,
Right.
all right, I'm going to order some crystals, some computer crystals, 5 megahertz. And they came. So I got a whole bag of 5 megahertz crystals, and I had the 23.1 megahertz VXO rocks, and it worked out very well. I didn't have any problems with that at all. But you're right, you have to kind of think these things through. Noodle,
right.
hey, I got one other. So this is, you realize you're in kind of an esoteric world here, when you could exchange kind of funny stories from the world of IF selection. Doug DeMoss, I mentioned the Barebones Super Hat. It's one of my favorite rigs by Doug DeMoss. My first Super Hat receiver, my first receiver that really worked well. And he used your beloved 40673 dual gate MOSFETs. But for the filter, and this was at a time when there was not a flood of computer crystals on the market, but what there was a flood of color burst crystals from TV sets at 3.579 megahertz. There were millions of these things. So I was able to order it. I forget who I ordered it from, but I still have it. It came in like a paper lunch bag, like for your sandwich, and it was filled with 3.579 crystals. I still have them. I must have 40 of them in there. And that was the IF for his 20-meter SSB transceiver. And then he had, I think it was, the VXO was running at around 17 megs, and then it got you down to 3.5 for 40 meters, for 20 meters. But anyway, when I first built this thing, I had it spread out on the board, pretty much like your 2x2 breadboard, and I had no real shielding installed, and I fired it up, and I got it working. And I was listening to 20 meter CW, so I was really elated. It was great. It was working. The thing was alive. But I noticed that I was also listening to some other stuff. And one of the things that there was some breakthrough, and I was listening to kind of evangelical broadcasts from some part of the shortwave band. But even worse was it was so close to the W1AW code practice frequency. W1AW was skipping right over my front end and going right into, through just pickup in the wires, it was going right into the crystal filter and the IF amplifiers. So I almost felt like W1AW was kind of scolding me for turning away from CW. They're saying, see, you built that phone stuff, that microphone stuff.
Yeah.
I guess you really do have to be careful. But I wanted to congratulate you, Pete, on one of the things that I thought was really a stroke of genius. And I remember I saw this. It was probably in your article in QRP Quarterly, and that's about your 17-meter sideband rig with the 4.9152 filter. You came up with an ingenious use of the 11.52 megahertz crystals for the VXO. Tell us about that.
Well, actually, I was struggling with how are you going to come up with a 23 megahertz signal local oscillator. And actually, I went on one of the forums, and I asked, did someone have any good suggestions? And the guy that wrote the 2N222222 transceiver, is it Bill Corti?
Yeah.
K8? Yeah. He came back and he said, have you thought about a frequency doubler? And the light bulb sort of went on. I said, no. So I got the breadboard out, and I figured out how to do the frequency doubler, and it works. It works beautifully. And the bonus is the VXO by itself has a significant frequency spread. Now you double it. And so this really gives you the leverage of a wide frequency spread with frequency stability. If we could take a moment and talk about VXOs, because some may not realize what that is or what may be involved. Okay, first of the concept of a VXO with sideband radios is not really a new or recent thing. As a matter of fact, there's a guy that used to, Ben Vester was his name. He wrote a couple of articles in QST with regard to sideband radios, and he used VXO. This was 1960. Matter of fact, he had a 15-meter tube-type single sideband transceiver on 15 meters. He used an 8.8 something or other filter and a 30 megahertz VXO. So he was able to get 50, 60 kilohertz on 15 meters, which was amazing. And then he had another article on a really small transceiver that used, again, the same IF, and he used, had that on, he made a 20-meter mobile, I think, out of it. So, yeah, the concept of VXO is, it almost seems like jumbo shrimp, you know, an oxymoron. Here you take a crystal oscillator that's supposed to oscillate on one frequency, and now suddenly you move this thing around. And if you really look at what makes up a crystal oscillator, it's represented by inductors and capacitors. So by creating this oscillator and putting some inductance and capacitance external to the crystal itself, you can move that frequency around. And depending where the crystal is, depends upon how much movement you get. For instance, if you had a 2 megahertz crystal, it's not going to move very much in a VXO. If you have a 12 megahertz crystal, it's going to move a lot more.
Yeah.
So the 11 will move, 20, 30 kilohertz. You double that, now you got 60 kilohertz, and now you got a major portion of the 17-meter phone band as a result of this doubling action. So, and a VXO itself, with a single crystal, is different from a super VXO. A couple of hams in Japan came up with a concept of a super VXO, where instead of just using one crystal, you take multiple crystals, all the same frequency, parallel them, and now you can get a really much wider frequency swing as you vary the inductance and capacitance. And so that's where the concept of the super VXO came. And I think this is a marvelous approach for homebrew single sideband transceivers, unless you go to something more expensive like a DVS. So the option is, if you can pick the frequencies right, you can get really good coverage, and there's nothing to prevent you from having a switched crystal oscillator like I've done in some radios, where you take two crystals, or you take the VXO and then you take a fixed frequency crystal and you heterodyne those two, and then you can have several crystals. Like, for instance, if you had a 12.96 megahertz VXO with a couple of crystals, then you mix that with a 6 megahertz frequency, that gives you 19. You take the 49152 and put you in 20 meters. So there are a couple of standard 6 megahertz crystal frequencies that you could use as a fixed crystal oscillator to mix with that, and you get a very, very large spread. So there's a lot to be said to the VXO, because once you move the frequency, it's rock solid stable. But it's the idea you're able to adjust the frequency over a spread.
No, I agree with you. And, I got introduced to VXOs by our honorary mentor for this show, Doug DeMaw. And he was very big on VXOs. One of the main reasons he was so big on VXOs was because he was also so into portable operation. And, he realized that, especially at the higher HF frequencies, trying to have VFOs out there where the temperature is changing and where the rig is bouncing around in your car, your luggage, it's difficult. So he was a big advocate of VXOs, and I agree with you that especially for people who are new, especially to sideband, it's a really good idea to look for rigs that employ a VXO, because you really need that VXO to be on the right frequency. And if you're going to build a VFO, a standard VFO, it's a little bit more difficult to get it on frequency, to make sure it's where you want it, to keep it there, to stabilize it. So, in these two BitXs that I have here to my right, the first one, the BitX17, as I mentioned earlier, does use a VXO. The second one, I decided that just for a technical challenge, I wanted to build and try to stabilize a real VFO. So I picked a fairly low frequency. It's oscillating it down at around 3 megahertz. And so the lower the frequency, the easier it is to get stable.
Right.
And I followed kind of all of the lore and the tribal knowledge on how to make it stable. For example, they tell you that if you use a toroid for the main coil, that could be a little bit problematic because the toroid is very temperature sensitive. Well, more temperature sensitive than air. So I use an air core, and I use the little cardboard tube from a coat hanger. When you go to the dry cleaners, they give you these.
Oh, yeah.
So I cut off about 2 inches of that and wound the coil, got about 3 microhenries, and put it in. That's what's in there right now. I didn't have to do a whole lot of temperature compensation, but it's pretty stable. It's especially stable if I leave it on for a long time and it reaches thermal equilibrium. Of course, you don't have to worry about that at all with the VXO. You just turn it right on and it's stable. So I'm a big fan of VXO. I've never tried the Super VXO, but you're inspiring me here, Pete. So I think I'm gonna go the Japanese model and do a Super VXO. Let's see. Now, but here's a kind of a philosophical point that we've reached, and I have struggled with this recently, and I know that you've made some progress in this area. When you build the BitXs or rigs like this, or when you think about building Farhan's new rig, the Minima, in the Minima, the VFO or the VXO has gone digital on us. They're using Arduinos with SI570s, or some guys are using Arduinos with the DDS chip, and I know you've done a lot of work on that. I have for now, shied away from doing that, just out of because I kind of try to stick to circuits that I know and like and enjoy, and frankly I found it a little bit frustrating to work on the microcontrollers and to have to struggle with the software and the computer interface. So, realizing that you should only just sort of work on stuff that you find fun. That's why I've kind of gone away from the microcontrollers and the Arduinos and the SI570s and the DDS. But I recognize that I need to make some progress too. So what do you think about that? About bringing this very sophisticated microcontroller and microprocessor technology into rigs that up until now have been really remarkably simple?
Well, it's almost the case of once you try it and see the benefits, you'd say, why didn't I do this a long time ago? I mean, as I heard you describe about building the VFO, I've worked on those, and you find yourself just saying, oh, please don't drift, please don't drift. And, you add capacitors, and there's all kind of tricks and techniques. But I've kind of gone through a series of various devices. For instance, one of the things that has worked really well is the frequency stabilizer approach, where you have a microcontroller that essentially measures the drift and creates a correction voltage. So this is great for older rigs and standalone rigs that that are maybe old boat anchors, and the only problem is they drift a little bit. And I've tried those, and they work really well. As a matter of fact, the first BitX that I built right after Farhan came out with his paper on it, I put an EI9 GQ VFO stabilizer onto a standard 5 megahertz VFO, and boy, that thing was great because the benefit is you get a digital display. I've tried the 570s, and the current stuff I'm using is mostly the DDS chips. And I guess the other piece of that, Bill, is the cost. You can buy an Arduino Nano for $9. You can buy the DDS chip for $4.58 and the digital display for about $10. So, for about $25, there you got it. And there's some software available that lets you make it band switched, so you can put it on different bands. There's some commercial kits that are available. I tend to like those because now you've gotten used to the technology of a digital display, and so it's nice to look at the frequency, and someone says, I want to see in 14200, you put it in 14200, and there it is. It's on frequency. But that doesn't negate having a lot of fun with a VXO type rig and sort of having an analog dial and saying, yeah, I know exactly where that is. But I just think that the technology is here, and once you avail yourself of it, it's sort of say it's hard to go back. You know,
Yeah, I know.
It's hard to go back.
Yeah, well, it's and I found that because I have built the Arduino with the DDS, but I built it as a piece of test gear, and it was almost shocking how useful it was, especially when building a crystal filter. Because after you build that filter, when you try to test the characteristics of the filter, you really need a signal source that you can measure with precision, and that you can vary with precision. That's something I could never do with the HeatKit SG6 signal generator that I have up there, right, or really any other kind of non-digital signal generator. But with the DDS, I was able to put the signal at the input through the appropriate termination, and then just vary it, and I would move it. I could move it at 10 hertz increments or 100 hertz increments.
And plot it.
I actually sat there and plotted it by hand. I just took the readings. I hooked up the Ricoscope at the other end. I looked at RMS out, and as I varied by 100 hertz, I just wrote it all down. And, you know, it was really, you know, I was able to come up with a graph that showed the exact characteristic, how much ripple I had, what was the bandwidth, what did the skirts look like. It was really, really great. So I know this is the wave of the future. My New Year's resolution was to sort of divide this and say that I would use this technology in test gear, but in the rigs, I would stick with VXO or VFO technology. But I feel myself slipping away from that resolution. You know, those resolutions, they usually don't last past St. Patrick's Day, you know, so.
Yeah. Well, the other thing too is a size issue, Bill. For instance, you put using an Arduino Nano and one of the DDS boards and digital display, it takes up real estate. And if you're trying to build, go back to this point of portable equipment, if you're trying to go back to something pretty small, a VXO can operate, can be constructed in a relatively small space. And so if size becomes an issue, and in portable operation, you may not need, be able to read hertz. You just want to get on and know within approximately in the band where you're at, and that's all you need. So, it's a trade-off. Now, if you're building a station, home station radio that you say this is going to be my principal radio, I mean, I was always kind of taken back by Wes Hayward, W7ZOI. You look at his station, there was not a piece of commercial equipment in there. I mean, when he got on the air, it was all, you see pictures of the station, it's all homebrew. So if you got something at home, you'd say, well, maybe I'd like something with a digital display on it. And so you may want to make that option. But if you're operating portable, then size dictates things. Matter of fact, I've got here the little, and I don't know if you can see this or not, this is the little 2x2x4 single sideband transceiver that I built, one of the projects. But right here is the VXO. And this is a crystal switch VXO. There's two crystals. There's a front panel switch right here to let you switch. I can cover 120 kilohertz of 20 meters with this little radio. And that'd be hard to do with an Arduino and an LCD display. And the thing is, most of the size of this radio was dictated by the knobs on the panel space. I could have made it smaller, but I'd have no way of tuning it or where do I plug in the mic and where do I do these other things. So I think, everything has its place. And in this kind of thing, if you wanted something you can throw in a knapsack and put a couple batteries in it and some wire antenna, this is a 1 watt, 20 meter single sideband transceiver here in the palm of my hand.
Oh, Pete, we gotta talk more about that, because I had hoped that we were going to sort of focus on that particular rig, and we've talked a lot about the philosophy and the circuits that have gone into it, but I think we should talk more about that rig in particular. And there's a couple of many other subjects on homebrewing that I'd like to spend a little bit more time on. For example, on the stabilization of RF amplifiers, or the exorcism that is required by an RF amplifier.
Yeah, right.
And I know this is a topic that it's painful to talk about, but we need to talk about it because I get a lot of email from guys who build something and they say it's oscillating, and then we go through the agony of the exorcism. But maybe we should leave that for the next program. If you'd be willing to come back and talk
Sure.
more, I think that'd be great. We're right at about the 1 hour point, and I have got to take my daughter to Target to buy something that's extremely important. I don't know what it is, but I'm told I gotta be there.
Just get out the plastic. Just get out the plastic. Well, it's a delight, and you know, this is subject you can't cover in 1 hour, and I'd be glad to come back and you know, maybe some input based on this podcast from some of the people viewing it. I'd be happy to try to cover any subjects that, you know, that maybe I work with that might be of some interest in a future podcast.
There you go. So listener participation. So if people should send us what they would like us to talk about, what they would like Pete to address on the next program, and we'll do it that way. Pete, I also know that you're helping a young radio amateur in the area there who's more kind of digitally inclined, and you're trying to share with him the tribal knowledge. So I know that experience kind of informs your comments here, and that's very useful for us.
You bet, and I'm learning a lot too. The digital age has almost passed me by. You know, where someone is working with this every day. I mean, you'd like to get your hands on it, but you just don't know enough. So I know what he's experiencing from not having a lot of experience with the soldering iron. I'm experiencing not having a lot of experience with the software.
All right. Well, there's a lot of stuff to talk about in future episodes. For now, Pete Juliano, thanks very much for joining us here on SolderSmoke, and have a wonderful rest of the Memorial Day weekend.
You too, Bill. Looking forward to our next chat.
7-3, Pete.
7-3.